So here now we have again a batch of mixed material. Some stainless steel in 3/16 or 7 gauge, some 1/4 inch aluminum, more aluminum, a whole grit basically for optical. This side also has PVC on it, but the PVC is very bubbled, as you can see. So that of course will have a little bit of an effect, and it may not stay on in the narrow grit in between. We have some very, very small parts. For this, what we did, you can notice this from further away, I just cleaned my conveyor belt. I cleaned the strap basically, where I can run smaller parts, which would be necessarily for those. Those all here would run on a standard conveyor belt. Of course, from time to time, you always have to clean the conveyor belt. And this aluminum basically is blank from both sides, as this stainless is. And also, these parts are blank from both sides, but here, whoops, sorry, this one belongs here. Put that here so I can remember what the thickness was. That's more 1/4 inch steel. And then we have one more with PVC coating, and that PVC coating is very good. We should get excellent results here. Yeah. So all we going to do is we are going to start with the 1/4 inch, the steel over there, and let's get going here. So this is our 1/4, and we are just going to put these here. I'm going to fast. So down to about 3 feet a minute. What I'm running right now. A good edge rounding. And this is the very first part, and I can't tell you that we have our brushes set heavy enough, but we will see that as these parts come out. We are looking for the white line for the silver ring to see what we're doing from this one. And that looks okay already, but I think we can do a little bit more. You see that we have a little bit of a structure here on top. There is no RA to that. I mean, you see that we have these white lines, you see that we have a radius, so that's pretty good already, but we don't have a lot of temperature, and that structure will go away if we just go a little bit heavier. So we're going to go a half a turn more, which is about 1 millimeter deep for the 40,000 feet running. And we are going to repeat the exercise here on this side. Now with long narrow parts like this, you need to be a little bit careful. You cannot always just build a table. It could be that you have to put one on the left and one on the right, so that the pressure rolls balance them. Or maybe you can put 3 or 4, but you wouldn't want to fill the whole table, because then they start shifting in between and bouncing into each other, which per se is not so bad. But if you don't have a gap between the parts, the edge rounding won't be as good. And now here you see that you have way more radius. And we have a little bit more temperature, and you don't have that structure on the surface. Okay? And I mean, you have the video, you can always cross-reference, but I will write for you real quick here. So this is 4 feet per minute, and that is, the pressure is plus, and that's 4 feet per minute, pressure plus, so that you can already get my notation. And this is 4 feet per minute, and the pressure was kind of so-so, right? Average. Okay, so from here we go right away into these 8 millimeter parts to see what we can do. Believe it or not, but for the small parts, what we're going to do is we're going to turn that belt up to about 4 feet per minute. Okay, and the parts have a little bit of an engraving in the back, and then they are Versailles. So I'm going to run these single file so that they don't lift the pressure over. And then we need to see if they will hold well. I think they will. Fine. we have heavy brush on the part, and this is what's causing it. So, full disclosure, my first attempt with those went horribly wrong. They got tossed, and actually it was my doing, usually, operator error. First of all, I'm setting these a little bit lighter again. I turn them back a turn, so they are only in 3. I never changed from 1/4 inch to the 8mm thickness of this part. So the brushes were in way too heavy. And then what I can also do is I can reduce the brush speed a little bit. You hear it in the sound, so that they run a little bit quieter. So now they're going to give this a try again. Of course, they have already run a little bit, so you can see a lot of the work is done. All I want to demonstrate to you here is that you can run in a setting where they do hold, because this is the part that you can absolutely run. I apologize for that. Again, operator error. And here you see him coming out, nice and stable. All in a row. And we will do right away the back side as well. You can see here on the imprint that they didn't move on the belt at all. So again, sorry for that. There we go. Now we are going with the side that has the little ring stingray. I can hear the brushes working on the part. Of course, we are working lighter now because we have slowed the brushes down to reduce the lateral forces, and at the same time we set them lighter, and of course we set the machine to the correct working level. So, and this is what that part looks like when it comes out. You see the little white ring even around the smaller opening in the center. The parts have a tap at the end here. Of course, that we cannot remove. That you would have to remove by hand. So, I think those are very nice parts. You should be pleased with that. So, moving on right away to the 4.5mm stainless. Let's put those parts on here, all 4 of them. We are going to run back, we're going to go back to 3 feet a minute, and of course we need to go to the 4.5 here. You see how quick that is doable. I didn't even hesitate to put the parts in already, and then make the quick adjustment for the height. So, and I'm not going to write on here, other than on one part, I'm just going to do 4 feet per minute. And this, by the way, wasn't 4 feet per minute, it was more like 3 feet per minute. Sorry for that, too. Slower. So, here we are running right now about 3 feet a minute, maybe a little bit less. There we go. And that looks good already. But I think for this one also, what we can do is, again, because the parts to hold, we can go a little bit heavier. And I am also going to go to full speed on my brushes. On the conservative side now, we have a little bit of temperature in the part. You see, so we like the result. Let's call that 30 inches a minute. And actually I'm going to run the other side for you because it was a little bit light. And I will mark that this is 2 passes, so this is 30 inch per minute, one pass. And the P is plus. Right? And they are all the same. I'm just doing this. Okay, and then on the other side, as you can see here, so this was done very light, a little bit faster, still the bird, but a little bit less. I am going to run this for a second pass the other way around, and what I want to do here is I am going to go about 4 feet a minute. And I just want to demonstrate to you how many parts a minute you could run with this. So you would put 1, 2, 3, 4, 5, 6, 7 parts side by side. And then we are just watching how fast they are disappearing from entering to exiting. And that's about 5 seconds, 6 seconds. So you would run 70 parts per minute, and at 70 parts per minute times 60, you would run 4,200 parts per hour. You cannot load these parts that fast. That would be literally impossible, but just to give you an idea how much speed you actually would get with those parts. So this was now at about 4 feet per minute, and with the second pass. So even if you went significantly slower, you would still make way more parts than you could ever do by hand. And I'll put a 2 here. Okay. Saves me some writing. Appreciate that. So, same thing here. Here we go with the same setting. Alright, same part thickness. Obviously those are the blanks that they were cut out of. I think somebody did a little bit of nesting here. So now we have the same setting as here, but it would be single pass. Okay? So then we're going to go back here to about 30 inches a minute for the other side. Even with these parts, you would run almost 1,000, probably more than 1,000 an hour. And you see, we have a very nice finish here on the edge of snow. Oops. I wanted to slow this down right now. And as you notice, I'm my own cameraman. I'll try to time this for you here. When the parts come out, so they are fully up. There they go. So that's about 5 seconds. That's about 10 seconds now. So 12 seconds, call it 5. You could run 1, 2, 3, 4, about 6 of them if you interlope. So 5 times 6 is 30, would be 1,800 single side per hour. So this was 30 inches per minute. Then the reverse side is 4 feet per minute, or 48 inches a minute. And you need to be careful because you have a burr side and you have a non-burr side. And of course on the non-burr side, you always get more edge rounding because you need to remove less dross and burr. Okay, but any case, good part, but you can have an idea basically what you can do. Of course, the faster you go, the less abrasive per part you have, and so forth. So now we are going back. Actually, let's do this. This is a 3mm part. What we're going to do here is we're going to set this to 3mm. At this point, we are slightly in the conveyor belt, so I'm going to bring this up by a half a turn, which is 40,000. 45.6. It's just about 46, that's about 3.5 millimeters, about 125,000, 130,000 below the surface right now for the brush. So we are just so up to the conveyor belt. Looks very nice, 30 inches. Now, on the non-burr side, where we have this, what we are going to do, very simple. We're just going to go a little bit faster here. We're going to go back to our 4 feet per minute. Just to be a little bit gentler on the CPC. Great edge. Basically what you burned off with the laser here on that one corner, we have a little bit more, right? But overall, really good result and a fantastic edge. So, and then last but not least, we're going to go here. Again, we're going to keep the speed up to 4mm because it's aluminum, but we need to go to 1/4 inch setting, 6.5mm. There the parts. So you see how I'm basically changing on the flight between materials, thicknesses and so forth.